Dear students, in this session, we are going to see about Ohm's law. So, at a constant temperature, the potential difference across the conductor is directly proportional to current flows through it. V is directly proportional to current I. So, in order to remove the proportionality, we have to substitute the constant, that is a constant value. That V by I is equal to constant. That constant is called as, we can say that, resistance of the wire. So, V is equal to IR is a Ohm's law at constant temperature. At constant temperature, the potential difference across the conductor which resistance R is directly proportional to the current flow through it. The SI unit of resistance is ohm. So SI unit of resistance is ohm. We can put a symbol like this. It is a omega symbol. So as these are all the things we are studied in 10th standard itself. I will recall you. The factors affecting resistance. So the resistance is directly proportional to length of the wire and inversely proportional to area of the cross section. So resistance is directly proportional to length of the wire and inversely proportional to area of the cross section. So in order to remove the proportionality, we have to put a constant is called as a resistivity of a material. So R is equal to rho L by A. Rho is a resistivity, L is a length of the wire, A is a area of cross section. So there is a 4 factors affecting. So the resistance will depends upon the rho, L and A, and also it depends upon the temperature. So there is a 4 factors depends upon the resistance of the wire. So we should keep the temperature also. That's why Ohms say that at a constant temperature only this law will be obeyed. If the temperature changes, resistance will be varied. That's why we can include the factors affecting the resistance temperature also. Hence, the resistance is a changes with length, area of cross section and resistivity. So when these 3 parameters, even the temperature also changes, what will happen? The resistance of the material will be changes. But the resistivity is a material dependent. It does not changes with the dimensions, length and area of cross section. It will change only with the material, and also it changes with temperature. It is a temperature dependent. So very clear, resistance is a dimensional dependent and resistivity is a material dependent. The SI unit of resistivity. Dear students, already I told you that don't mug up any SI unit. If you are confused with the calculating the SI unit of the any given physical quantity, substitute the formula first. So R is equal to rho L by A. So R is equal to rho L by A. Rho is equal to RA by L. Rho is equal to RA by L. What is SI unit of resistance? Ohm. Area is meter square. Length is meter. So just you strike out these things, we get a SI unit of resistivity as ohm meter. So again, these are all the things we have studied in 10th standard itself. I will recall you what will be the changes in dimension of the wire. If the length is L and the area of cross section is A, the resistance can be given as R is equal to rho L by A. If the length is doubled but area of cross section does not change, that means the length of the wire is, instead of 1 meter I will take the 2 meter wire, but the thickness does not change. What will be the change in resistance? Substitute 2L here, we get 2R. So the resistance of the new resistance of the wire is 2 times of the previous one. If the length is same but the thickness of the wire is doubled but the material is the same material, that's why we cannot change the rho value. So all these cases the material is same, only the dimensions, length and area are differ. If you substitute 2A here, we get the resistance is halved. Similarly, when the length is increased doubled and the area of cross section is halved. This is the case when the wire is stretched. When the wire is stretched, elongated means the length increases but the area of cross section, the thickness of the wire decreases. If you substitute these values, we get the new resistance is 4 times of the original resistance. If the length of the wire is doubled on it, if it is doubled on it means folded on itself, that means the length is half and the area of cross section become double. So the new resistance will be R by 4. So these are all the things you should keep in your mind for the problem solving purpose. So I will show the pages slowly in order to copy in your classwork note. Ohm's law. Yes, we are already studied in 10th standard itself. Just this is a recalling session. which is included in our plus 2 syllabus itself. So it is a easy topic to score mark in exam point of view. Sometimes the students may argue with me, sir, current how it is a scalar? Yes, I am saying that current is a scalar, but the current has a direction if it is flows through the material. So very simple, let us take a wire. So this is the area of cross section. The battery is connected. So this is the key. What will happen? The current flows from positive terminal to negative terminal. The direction of the current is shown here. The current enters into the wire here and goes out here. But the area is direction dependent. Let us see that. See my hand. Here this pin. This is the end of the pen which shows the tip. This is the direction of the face which is this side on the right side of my hand. So if you want to see the left side of my hand, what will happen? So we have to change the direction. So if it is the same area of cross section but the direction is differ. The same thing here, the area of cross section is here. The direction vector is this direction and here the direction vector is this direction. This area is facing in the left side and this area is facing in right side. So the area of cross section is a vector quantity. So the current density can be defined as the current flows through per unit area. The current I flows through per unit area of cross section is called as a current density. So current density is a vector quantity. So current I is equal to J into A. So it is a horizontal direction. It is a x-axis direction. We can put x component cos theta. So in vector form, current I is equal to J vector dot A vector because JA cos theta. A vector dot B vector is equal to AB cos theta. So the product of two vectors, we get a scalar value means we have to multiply with the scalar product. So already I will remind you. So the product of two vectors, if it is gives a scalar value, so we have to multiply as a scalar product. So even we can write that integral ds which is equal to area of cross section. So we can put that integral form of current which is equal to I is equal to integral j dot ds vector or I is equal to integral j ds cos theta. So this is a current density. The current is a scalar but the current density is a vector. Now this is a scalar form of Ohm's law. Now we are going to write the vector form of Ohm's law. So since V is equal to IR is a scalar form of Ohm's law, we know that V is equal to electric field into length. Sir, how sir it will comes? Very simple. Already in the second chapter we studied that electric field E is equal to minus dV by dr potential gradient. So simply in scalar form we can write that E is equal to V by thickness. So that is we can write that V is equal to E into thickness, that is the length of the wire. So V is equal to EL. R is equal to rho L by A. R is equal to rho L by, already we studied that rho is the resistivity, L is the length of the wire and area A is the area of cross section. Similarly, the current density J is equal to I by A. Substitute these values in the scalar form. So V is equal to EL. V is equal to EL which is equal to I as it is I put, and instead of R we have to substitute rho L by A. The L in the right side and left side get cancelled. Then E is equal to, I will bring the A here, I by A which is equal into rho. What is I by A? Yes, I divided by area. Current by unit area is called as a current density. We can put current density J vector. Electric field is a vector. Then rho is a resistivity. So the resistivity and the conductivity are inversely proportional. So rho is equal to sigma. Rho is a resistivity. Sigma is a symbol for conductivity. Resistivity which opposes the flow of charge. Conductivity is a property of the wire which favors the flow of charge in the wire. Resistivity which opposes the flow of charge in the wire, and conductivity which favors the flow of charge in the wire. So both are inversely proportional. So for rho we have to substitute sigma here. So very simply we can write J is equal to sigma E. J vector which is equal to sigma into E vector is a vector form of Ohm's law, where J is a current density and sigma is the conductivity of the wire and E is a electric field. So I will show you students in order to write the classwork note this page very slowly. So current density, and a very important question, vector form of Ohm's law, which is frequently asked in 2 marks or 3 marks in exam point of view. Yes, thank you students.